Transformation of reciprocal functions. So we have talked about the reciprocal function of this form. This is a parent function, y is equal to 1 over x. We also talked about this a factor when you have a number that is other than 1 as top of the x. Then what a does is, if the absolute value of a is bigger than 1, the graph stretches. If it's less than 1, the graph shrinks. And if a is negative number, it flips across the x-axis. So we are kind of familiar with these two different forms of the function. Now, in this video, we're going to learn about the translation. So therefore, we're going to learn about y is equal to 1 over. Instead of x, I have x minus h. H is just another number. Plus k. K is another number. So when you have this form, you notice that x became x minus h. So what it does is, it translates the graph by h unit to the right side. This k number shifts the graph k units to the up. So h and k do the horizontal shift and the vertical shift. One thing that we have to be careful is, in the original function, we always had the asymptotes of x-axis and the y-axis. Now, that didn't really change. But as we shift our graph right h up k units, then our asymptote is gonna change along with the graph. So when you look at this combined form of function, y is equal to a of x minus h plus k. So a is a stretch or shrink factor, or sometimes it reflects if a is a negative number. H is a horizontal factor and k is a vertical factor. So for example, if I give you the graph of the function of y is equal to 5 over x minus 2 plus 3, now we know 5 is a, h is 2, and k is 3. So we want to compare that with our parent function, which is, well, not the parent function, maybe 5 over x, the one without the translation, 5x. And then we can maybe graph that first and then translate that graph 2 to the right and 3 up to get the red graph. So let's just plot some point. When x is 1, y is going to be 5. When x is 5, y is going to be 1. And as we know, it's going to be some curve that looks like kind of like this one. If you plug in negative 1, you will get negative 5 as our y. If you plug in negative 5, then we'll get negative 1. So it's gonna be this mirror image, these two curves that are symmetrical across the origin. Now we're gonna translate that right 2 and up 3, because that's the h and that's the k. So if I do that, if you look at the original, the black graph, the asymptote is this line and that line. If I move everything right 2, then that line is gonna move 2 units, and this is gonna be our new asymptote. Right, 2 to the right. And then this line, if I move everything up 3, this line will move up 3, and this will be our new asymptote. So that's our new asymptote. And then, well, for example, that point will also move up 3 and right 2. So if I do that, 1, 2, 3, and 1, 2, this will end up being here. And that point will move right 2 up 3, which is right here. So we're going to have a curve that looks like that. This point too. This point will move 2 right, 3 up. That will move 2 right, 3 up. So we are gonna end up with this curve, which are the exactly same shape as the black one, but just kind of different location. So we call it translation. So that's one of our example. Let's look at example number 1. So what is the graph of y is equal to 1 over x plus 1 minus 2. Identify domain and range. I guess that should be graph. What shape is the, well, I don't know what it means. What is the graph of that? So identify domain and range. So let's just draw that. Draw the asymptote. I have a lot of typo here. Draw the asymptotes first. So the original graph will be y is equal to 1 over x, which will have the asymptote of x-axis and the y-axis. Now that axis, that asymptote is going to translate 1 left and 2 down. That means our new asymptote will be 1 left, which is this line. So that's our new asymptote. And then 2 down. So this line becomes down 2. So that's our new asymptote. So we draw the asymptotes, the horizontal asymptote and the vertical asymptote. And now second step is to plot a few points and sketch the graph. Well, we know the asymptote, but we don't know the graph, where it's going to be like that or that, we don't know. So we can just plot a few points. So let's pick up easy point. Easy point, by easy point what I mean is we don't want to have fraction out of this. So what's the number that you can just plug in and not have fraction? Well, you can plug in 0. So if I plug in 0, 0 plus 1 is 1. So 1 out of 1, 1 over 1 is 1. 1 minus 2 is negative 1. So we have 1 point, which is 0, negative 1. If that's the point, we know this point is symmetrical. We know that another point that is symmetrical across this point must be on the other side. So we can just plot that. If I plug in 1, I will get 1 over 2, which is kind of a fraction. So maybe we can instead plug in, well, actually that might work too. So if I just plug in 1 over 2 minus 2 is 1 over 2 minus 4 over 2, which is negative 3 over 2. So plug in 1, I'll get negative 3 over 2, which is right here, which is negative 1.5. So we kind of get some idea, because that graph is here, that means that point should be here. So if I plot that, I will have a graph that looks kind of like that. So the domain of this function would be all real number. X can be all real number except this number, which is negative 1. Range would be y can be any number except that number, because we don't have any graph right here, so that number is negative 2. So these are the domain and range. So the steps are just find the asymptotes first, and then from there you just plot a few points to get the general shape, and then find the domain and range. And you can kind of check back, well, this makes sense because our a, the number on the top, is a positive number. So the graph should be on this side and that side, not the other sides. Let's look at the second example. Okay, this graph of a function is a translation of the graph y is equal to 5 over x. So we had y is equal to 5 over x, and then we translated the graph vertically and horizontally, and then we end up with that graph. But they don't tell you how many units we moved up or left, up and down, left or right. So we have to figure that out. But luckily we are given this graph. Graph tells us the asymptote, the vertical asymptotes and the horizontal asymptotes. So when you look at the asymptote, the original asymptote must have been this y-axis. That means from the original asymptote we moved 2 units to the left. That means the whole graph shifted 2 to the left. If you look at the horizontal asymptote, we know from the original one we moved 1 down. That means the whole graph has moved 1 unit down. So that means when you have x minus h plus k, h tells us the horizontal translation, so our h is, because we move 2 to the left, x minus 2, actually x plus 2, because that's the opposite, and k is the vertical translation, which is down 1, so it will be minus 1, and we already know our a is 5, so our function will be 5 over x plus 2 minus 1. So you just look at the asymptotes, figure out the translation first, and then make up the function.